Hello everyone, my name is Architect Anna Corda and we will be discussing today site development and site grading. Everyone knows what site development is and you have been creating this since first year. First, let's define site development according to books. Site development is a general layout and configuration of a site including building footprints, parking and street layout, conceptual landscaping and lighting, site cross-section drawings, and building elevations. To simplify, site development is a planned arrangement of structures, hardscape and softscape elements on the property. So how do we make a site development plan? Like this, but before we draw the site development plan, we need to do a proper site analysis first. Site analysis. Why do we do site analysis? As architects, it's a no-brainer. We do site analysis to familiarize with the site, whether development is financially feasible, and establish parameters to implement the best design that responds to the physical and environmental features of the site. An architectural site analysis will look at issues such as site location, size, topography, zoning, traffic condition, and climate. The analysis also needs to consider any future developments or changes to the site surroundings, such as a change of road designations, changing cultural patterns, or other significant building developments within the area. Understanding the context of a site is key to enabling the designer to weave the new design with the existing fabric of the site. It allows us to understand the existing opportunities or problems in a site and makes informed decision on how to respond to our findings. This response could be that the design building reflects the surrounding context and is designed to be in sympathy or perhaps to turn away or eliminate certain unwanted site conditions. So under location, what are the different types of information do we need to be able to get information of the area or the location? Number one is the geological map. It is to discover predominant types of soil or rocks on the site. Next is the aerial photographs and maps. Like for example, Google and Bing have really useful and quite different aerial images. Bing map. Next is the historical maps. These can also be interesting. Historical mapping may be described as images which shows a particular event or time in the past or just contemporary map for a specific point in time, showing land use and settlement patterns as recorded at that point. Nice, no? Anyway, distance and travel times between the site and other locations of importance. Like, for example, our Google map has a distance unsa na siya? Measurement. So, you can even um, measure how far you are going to walk or how far you're going to get there to your destination. So, that's how easy Google Map made at this time compared to 1980s. Okay. For legal information, so these are right of way, right of access, town and country planning restriction, is the site in a green belt or not? So that's an example. History of the site as mentioned for the history map, but this one, it's the story or the history of the area. Anything you can use to inform your design. Any tunnels, disuse mined, archaeological interests, under the site could curtail development. And then, historical use of the site. This could be industrial processes that have contaminated the land. So, those are examples. Example, okay. If the site sits in a conservation area or close to listed buildings, you may need to go into more detail regarding cultural significance, historic significance, and etc. Developmental controls are sites subject to any specific planning control, building control, or health and safety policy or control. So, are there any trees on the site? Do they have trees preservation orders on them? So, that's the vegetation information. Okay, so that's for the legal information aspect. For utilities, we don't need to define each of these names here because it's self-explanatory. So these are water, electricity, gas, telephone, sewage, and other services that are connected to the land. Climate. So under climate are climate conditions of the site or area. Another is the sun path and angles, which is very important for architecture and their structures. Next is the area susceptible to flooding? Is it considered a flood risk area? In Cebu, we are vulnerable with landslides and erosion during heavy rains because of the type of soil. For areas near water or facing the ocean, these areas are vulnerable to storm surges during typhoon. So some information is not freely available, but a client or their legal representative should be able to clarify any issues regarding right of way, right of light, legal easement, and any rights of tenants. There are many more things to look at, and each site is very different, but hopefully this will give you a starting point for getting the best out of your site visit. In the next section, we will look at visiting the site and some of the items on the checklist according to the categories that you should look out for. Depending on the project, you will want to consider taking the following items with you when you go to look at a potential site or proposed site for your project. It is likely you will require PPE, which is the personal protection equipment. Di lang sa hospital na ay PPE. So make sure you have all the necessary items before heading to the site. PPE could mean insect repellents, boots for climbing or water boots, sturdy pants for harsh conditions of the site. Camera is also essential. Make sure you take pictures of everything. Make sure you get some shots of the site from a distance so you can use this in your final images. Also take pictures of what is opposite the site so you can use this as reflections in windows of your perspectives. It is so frustrating when you go through the trouble of visiting a site and come back wishing you had taken more pictures. Smartphones. If you have any apps that assist with making panoramic pictures, take a few of these too. You can do some interesting stuff when you get to later design stages if you have a few panoramic to play with. Notebooks are really important to be able to jot down any observations. Tape measures. Some sites may be close to hazards or situations where you will need to measure the proximity. If you have a digital measuring equipment like laser, it could also come in handy, but it is not essential. And finally, a good weather. If you have a choice of when to visit the site, try to pick a day when there is a bit of blue sky around. It it will look better for your site photos, particularly if you are planning on using them in future presentations. Okay, if you want to go to a site, what is the first thing that you look for? Diba, a map. So you have to secure a map of the site first. So location, under location, site location details, what are the road names, address, major landmarks, etc. And then when you get there, you look into the current context, the existing buildings, car parkings, roads, etc. Under neighborhood context, what do you look for? So look at existing and proposed building uses in the neighborhood. And then, what are the conditions that the building are in, especially if you are looking into an old town. What type of buildings are there? Are they, what era of the design, architectural design, is rampant in the area? Are there exterior spaces, and what are they used for? And then, are there activities in the neighborhood that may create strong vehicle or pedestrian traffic? And then, existing vehicle movement patterns, major and minor roads, bus routes, and stops. These are important when you consider your site selection or where your neighborhood could be. And then, the existence of street lighting. If not, you will have to introduce them for urban design. Another neighborhood contexts are vernacular contexts, meaning the materials, architectural features, fenestration, landscaping, parking, building heights. These are important if you want to match your structure or if you want your structure to stand out. And then there's another thing to look for: any historical buildings or buildings of particular significance, again to match your building to the existing urban space or not. And then the sun and shade patterns during the year. Under the building context, you need to look for what style, the period, the state of repair are the surrounding buildings. Is it historical or heritage or conservation area? Will your design need to reflect the existing style? Is the site close to listed buildings? Listed buildings are buildings that have significant meaning. Like, for example, is it a heritage building or an iconic building? Next is the surface and materials around the site. So that is for the neighborhood context. Now we are in site and zoning. What do you look for in site and zoning? Site boundary and dimension. It is the vastness of your site. When you look in a site in a map, it might look small, but when you get there, the area is wide enough to create an illusion of a bigger space. The borrowed landscape of the Japanese garden might be useful. And then, are there any rights of way through the site and the dimensions? Of course, you should know how the site is entered and how wide are the entrances. And then, are there any easement locations and dimensions? What are the buildable areas of the site? These can be determined through site analysis. Any building height restrictions, especially if you are in an airport or near an airport. Then, the access to the site, car parkings, bus routes, train stations, cycle routes, pedestrian walkways, etc. And then, access to site for construction. Will there be any obstacles or restriction that could affect the construction process? So that's very important. And then, there are these natural features. So obviously, these are the topography of the site, valleys, the ridges, the slopes, etc. And then there's the vegetation, landscaping, greenery, shrubs and trees, open spaces. And another is the site levels. How will this affect your design process? How does the site drainage work? Will there be any potential problems with drainage or flooding? And then the soil types of the site. So that's very important. Now we are in the man-made features. So what do you look for in man-made features? Number one are, what are the previous use of the site? Would there be any contamination concerns, especially if you are converting a sanitary landfill or a brownfield? Are there existing buildings on the site? What is the state of repair? Is there any sign of subsidence or settlement damage? Are there existing buildings part of the project? Or are the existing building part of the project, or do you have to turn it down? Any walls, retaining walls, or on the site or other built items are important to look for. Okay, for circulation, how do visitors or pedestrian traffics to or near the site flow around or within it? For accessibility, are there current provisions of disabled access to the site, and how will this need to be considered? Then, does the existing pedestrian movement need to be preserved? What is the vehicular peak loads and when? Are there public transport close to the site? What is the location of best access to the site for both vehicles and pedestrians? And then the travel time to walk across the site. So these are very important in site visit. So there's utilities. What do you look for utilities? The location of all services, especially electricity, gas, water, sewer, telephone. This includes both underground and above ground. Then the location of the power poles. Then the existing drainage or possible areas for drainage. And then the substation. These are underground electrical wiring, sewers, and tunnels. Sensory. So what do you look for? Views. Where are the best views to and from the site? What are the views for? Mark out the positive and negative views. Which is most likely feature aspect? These are any interesting things to look for when viewing the site. Any big landforms that attract attention? Or look at views towards the site from different approaches to see how the site would be seen when drawing near to the site. What are the best views of the site, and would these changes in the long term? Lastly, are noise, odor, and pollution. Is the site in a particular noisy area or near industrial buildings that produce levels of pollution? Is it near a facility that creates smoke or other things? Then, under the human and cultural conditions, like the negative neighborhood issues such as vandalism and crime, what are the attitudes towards the site and the potential build? What are the general neighborhood attitudes about the area? What are the cultural, psychological, behavioral, and sociological aspects of the surrounding area? What is the population density, family size, ethnic patterns, employment, recreation activities, etc.? Under climate, you have to look for orientation of the site. The weather. How does the weather affect the site? Is it well shaded or exposed? How does the temperature or rainfall vary throughout the year? What are the prevailing winds direction throughout the year? What is the sand path throughout the different times of the year and day? Take some time to walk around the site as much as possible. Take note of the general topography of the site and any significant changes in level Also note any indications of what is underneath the surface. For example, any marsh grasses could suggest that there is a high water table. If the soil is sticky, it could indicate the subsoil on the site is clay. If there's any rubble on the site, it could suggest there has been a previous development or possibly landfill on the site. Many of these issues, site issues, particularly services, would be picked up on a topographical survey or other professional report. But for the benefit of a student site analysis assignment, I think it would be good to demonstrate that you have to consider the hazards that could be on the site or around the site. The best way to present much of the data you have collected is through diagrams. There are varying approaches to expressing the features of the site. Some prefer to include as much information as possible in one diagram, where others will produce a number of smaller diagrams to demonstrate particular site conditions or features. These diagrams are represented with symbols, icons, of course, color-coded to differentiate every symbol, and then legend to identify what the diagram meant. And finally, map overlays where you can now compare each site information to suit your requirements for the design. But as you already realize this from your work experiences, it is not only climate that you need to consider in site analysis. Here's a short clip on simple site analysis for a residential layout. So now we are back to creating site development plan. Most of you, even though you already reached fifth year, always forget the basic features of the site development plan. The list here are the most important information that should be present in the layout. 1 is the structure, the major and the minor buildings. Next are the vegetation, which are the trees, your shrubs, and lawns. Next is the circulation, such as pedestrian and vehicular circulation. If possible, vehicular circulation must be indicated with flow arrows, especially on routes where one-way directions are restricted. Next are entrance and exit to the site, which connects to the access road of your property. Then, the finished contour layout. Not the existing contour layout that is the most common mistake in the site development presentation. Siyempre, it is already the developed plan of the site, so the contour layout should be the finished layout as what is indicated by each location in the site. Later, this will be explained in the site grading part. Then, the neighboring information means a label of the neighboring site, for example, agricultural, farm, residential, but this is only optional when the site development is not similar to the zoning. Then, labels are very important. We always forget that site development is for the client to see the whole development of his property. Labels are important for them to recognize your drawing. Your teacher are the substitute clients. Even though they can understand your drawing, the real client might not. And then last is, no, not the last, but next to the last is the bar scale. Bar scale is preferable than numbers because printing of the site development plan in any size of paper will assure the correct scale because of the bar scale. And then lastly, the north symbol. Orientation of the sun and wind by the client's perspective is important. It is also important to orient your site development plan where entrance to the site should be from below going up to the property, regardless of the north direction, just like this sample. Now let's go to site grading. Site grading is an important part of the land development process. We have different zoning and policies when it comes to what is acceptable in terms of site grading standards. The difference could be because of our soil type, location, climatic conditions, etc. So, in each site we visit, we should be able to know the local ordinances and requirements for each land developments before we go through designing it. When we do design, most sets of site plan documents are multi-sheet plan sets that will include a grading and drainage plan. In terms of drainage plans, we will always give this part to the engineers. Architects are not trained in this aspect in detail. A typical drainage plan contains information on pipelines for storm water drains, inlets, catch basins, manholes, and outlet structures. These can be learned with plumbing and engineering. For grading plan, this is a separate plan to drainage plan because this involves earthworks. Possible earth-moving activity, the grading plan defines the information that the proposed surface will exhibit post-construction. When we are doing the grading of a site, we must first be provided with documents that define the existing conditions. The main document is topography. So what should be in the topographic documents? One is the topographic survey. It is done by a geodetic engineer, especially if it is an old topographic map. Most of our maps in the Philippines is 50 years or older. Survey is where the cadastral points are. It sometimes happened that the old mohon, as we say in dialect, are gone. So we have to hire a geodetic engineer to look for the cadastral points of the site. Regrading information are needed, especially if there are new excavations done with the site. But the old topographic maps still contain the old topographic information prior to the excavation erosion, or new development. Spot grading and spot elevations are those areas specified with grades that are not within the contour intervals or with value that we will be discussing later. Contour lines are the lines that indicates the form of the topography with elevation value. Let us review first what we know about contour lines. Contour lines determine the elevation of a space. It indicates the lowest point and the highest point of the site. It also should have a constant interval. What I mean about interval is that the line should have a constant grade. If it is an interval of 20s, it should be consistent throughout the map. Major contour lines are indicated by dark lines, while the minor contour lines are indicated by lighter lines. Uniform distance determines a constant slope, and the wider the distance between slope, the flatter the surface, and vice versa. Lowest contour lines comes in pairs. Like in this drawing, if this is the whole site, the lowest contour line should come in pair, or else the contour map does not make sense. These are the samples of spot elevation symbols and how it is used in maps. It identifies the exact elevation of a point on the surface or level flat and usually shown in X or in a plus mark. Knowing the slope of the site is important in site grading. Doing site section helps, but it will not visualize the coverage of the slope in plan. Slope map will do that. It will determine on plan the extent of the slope as seen on map. This is an example of a slope map. The legend is not fixed. You can make your own legend according to your slope requirements. Next to slope is knowing the flood-prone surfaces of your site. Sites may have existing hydrology map where you can see where surface water run or flow. Having hydrology map will let us know what part of the site would be flooded during rain or if it will be a flood-prone area. Natural water features are also indicated in the hydrology map like springs, creeks, streams, rivers, and others. Sometimes water tables like aquifers are indicated. In the area where we need to do site grading, we should be able to know where all the water goes. So if our area is prone to accumulation of water, unless this is the intended purpose, we would not want any flooding to happen. So that's where we do site grading to lead water out of the space we want to use. In doing site grading, there is what we call positive drainage and negative drainage. Negative drainage is where water stands still on a place. That is not what we want on our site, especially on parking areas, play courts, or other open spaces where a volume of public will congregate. We need to be doing the positive drainage in site grading. So what is positive drainage? Positive drainage is water that has ability to flow away from the site, or there should not be any stagnant water remaining in the regraded site. These are the standard slopes for site grading. Maximum access drive is around 8%. The maximum parking lot slope is 5%. Slope steeper than 5% increases the frequency of runaway, shopping cart left by shoppers, or any equipment with rolling mechanisms such as baby carriages. Slope steeper than 5% keeps vehicle doorways open when parked perpendicular to the slope with doors on the high side. Maximum slope in maintainable grass landscape areas are 3:1 or 33%. Lawn mowers, the one that is driven by Forrest Gump, cannot climb more than 33% slope. 33%. Mulch beds, which are mulches that are covered to protect the plants, are placed on a 3:1 slope, and they do not erode from storms or relatively strong intensity. Maximum slope in stabilized landscape areas is 2:1. Slope must be stabilized with vegetation that helps anchors the topsoil. Slope exceeding 2:1 should be stabilized with materials that do not erode, such as riprap, gabion basket, paved or concrete finished slopes, or other kinds of retaining walls. My minimum slope of asphalt is 1:5. Minimum slope of concrete and concrete curve is 0.75%. For cut and fill, it will be determined by the amount of earthworks required in the site. The least amount of earth being cut or displaced is more desirable. Other grading features, such as berms, are mounds of soil or small hills that may be proposed in order to direct flow in a certain direction. The swales are the opposite. They are valleys or linearly defined low lines that are used to convey flow in some direction. Sometimes a swale can be used to divert a portion of flow from the site. The next slide is a clip on how to do site grading.